Hello, welcome to the next chapter. I realized at the very beginning of this slide says chapter 5, section 3. I am rearranging things, so please ignore that. What you do need to know is that we are now focusing on how electrons work, because when we talk about electrons, these are actually the most important. I'm not going to say most important, but these are one of the most important features that helps indicate how atoms will behave, how atoms will bond to create compounds, and whether that be covalent or ionic. So it's really, really important. When we talk about electrons, we are going to talk about, one, how they look in the cell, and then how they're organized in the cell, because there are various methods of organization used for the electron that are really important in understanding how and why some atoms have a certain sublevel compared to others. Again, I told you this in class. This information does get a little bit more complicated, so organization is a big key in this, with this information specifically. Also, I really, really would suggest starting to study now for this information rather than wait the day before the test. This can be a little frustrating if you wait till the last minute to look it over. I forgot to include an objective slide, so I am so sorry. But let's go ahead and start talking about electron arrangement. You should already know this. This isn't like news. The electrons exist around the nucleus. So there is a certain distance between the nucleus and where electrons happen. We talked about that area known as the electron cloud. Now, the reason why we don't know, and this is all part of quantum physics and quantum mechanics, but we don't know the actual location of an electron. This is because electrons move incredibly fast. Obviously, they're super small, but in regards to how fast they're moving within an atom's space, they move really, really fast. So to find the exact location of an electron is almost impossible. But there are equations out there known as Schrodinger's equation that will help us to determine or give you a probability of where that electron is. We are not going to focus on that portion, but we do need to talk about orbits and what this electron cloud looks like in regards to understanding levels and how many electrons are in a certain level. So a couple of vocabulary terms to make sure that you know. Remember, we have the nucleus, and surrounding the nucleus, we have electrons. These electrons are not just anywhere. They're not just like, I've been telling you they're in the electron cloud, so it makes it sound like they're just floating anywhere. No, more specifically, they are around these circular guys known as orbits. So I'm going to write it out here. These are known as orbits. And depending on how far out the electron is from the nucleus will determine what orbit it's in. It'll also determine energy level and so on and so forth. Typically, electrons that are farther out indicate much higher electrons as far as atomic number goes. We can also call these orbits levels, and there are 4 different levels. So level 1, 2, 3, and 4. The first level being the orbit closest to the nucleus. So orbit 1, known as level 1, orbit 2, level 2, orbit 3, level 3, orbit 4, level 4. When we talk about electrons, I want you to think of electrons as any type of thing out in nature. Everything in nature always tries to use the least amount of energy. Anything and everything. That includes your body. That includes the natural state outside. Everything tries to use the least amount of energy. So electrons are no exception. Typically, electrons like to be in what's known as a ground state. So lowest energy state of an atom. So they want to be closer to the nucleus than farther out. Excited state. So when these electrons in like the first and second and third orbit get excited, they will move levels. And this is all indicated from Bohr's model of the atom. We did not spend a whole bunch of time talking about that, but just know that when electrons get excited, they will jump from one orbit to another. So they typically want to stay in the orbit that they are oriented at originally in ground state. When excited, like as in there's more energy available, electrons will jump. They don't like to be there. They'll jump back down to that ground state when energy has depleted. In the previous slide, I talked about levels, and remember we talked about 4 different levels. Now you can think of this as like a filing system. So I have this big filing cabinet, and I want to go down even further and break things down even further. So in my folder, I have this level 1, this folder titled level 1. Within that folder, I can organize it even further and say I have subfolders in my folder, just like you would do on the computer. So for example, I have a biology folder. In that biology folder, I have it broken down between chapter 1, chapter 2, and chapter 3. And then in that folder, I have more folders. So just a bunch of organization methods. Levels can be broken down into what's known as sub-levels. So if I have level 1, I can have a sub-level in level 1. And I have 4 different sub-levels. Those are known as S, P, D, and F. At this point, you're expected to know this. This is the first time you've seen this information, and at this point, you just need to know it going and moving forward. Super important that you know that these go in this order: S, P, D, and F. However you want to remember that. Again, the sub-levels S, P, D, and F. Level 1. So I talked about how level 1 is closest to the nucleus. Level 1 has 1 sub-level. Okay, so level 1, 1 sub-level. That sub-level is the lowest, so it would be S. So there is only a 1S sub-level in level 1. Level 2 has 2 sub-levels. So now it can hold 2, so it would have S and P. So level 2 has 2 sub-levels. Those are known as S and P sub-levels. Level 3 can hold 3 sub-levels, so it has S, P, and D. Level 4 has 4 sub-levels, S, P, D, and F. Okay, hopefully that makes sense. 1 has 1 sub-level, 1 and 1, 2 and 2, 3 and 3, 4 and 4. So 1 is S, 2 is S and P, 3 S, P, and D, 4 S, P, D, F. SPDF, yes. And there are numbers associated with this. I'm going to talk about those in class, so don't freak out. I realize my notes as you turn the page or on the next page are a little bit more unorganized, and I had to get some things out, but I just didn't want to confuse you anymore because this information can be a little heavy. Let's talk about orbitals, though. Orbitals. This is actually the location that you can typically find an electron. So a space with high probability of containing an electron. So the orbitals are found within the sublevels. So we started at the level, we went to sublevel, and now we are going from sublevel to orbital. So each sublevel can now hold so much. And I'm going to give you an analogy in class, so don't freak out if you're like, I still don't get this. Orbital is a space with a high probability of containing an electron. Orbitals can only hold 2 electrons. Orbitals, I'm going to even write it because that's how important I think it is. Orbitals only hold 2 electrons. Super important. They only hold 2 electrons. So that means if an atom has a lot of electrons, where do they go? Well, I just told you that different sublevels have different amounts of orbitals. Or maybe I'm going to tell you right now. I don't know if I just said that. So an S sublevel has 1 orbital. So that means in the S sublevel, you can only hold 2 electrons max, and then you must move on. In the P sublevel, we have 3 orbitals. Each orbital holds 2 electrons. If I have 3 of those, that means the P sublevel holds 6 electrons max. D sublevel has 5 orbitals, so it can hold 10 electrons. And the F sublevel has 7 orbitals. It can hold 14 electrons. I know that's so much information, but when we talk about it in class, hopefully it seems just a little bit more clear. Like I'm talking about it, but when I show you and I explain it using Aufbau's principle, hopefully that it kind of clicks a little better. Now, why is this important? Why do we even need this? Well, when we're identifying elements, when we're talking about how elements can bond, super important that we know about the electrons. So it leads into electron configuration. Electron configuration. So electron configuration describes the arrangement of all electrons in that atom. So what those look like, how they look. Each element has a unique configuration. And this is because each element has its own number of electrons. If you remember from the last section, Ape Man, proton number equals electron number in a neutral atom. So in a neutral atom, every single element has its own number of electrons, its own unique number. So each configuration is going to be different. Now, when we start talking about ions, some may have the same electron configuration, but that's due to a loss or gain of electrons. All right, let's continue. All systems want to be in the lowest possible energy state. This includes electrons. So I already talked about that lowest ground state. So when we talk about electron configurations, we are talking about it from the ground state. So like I previously stated, electrons like to be in that ground state. So in order to determine ground state electron configuration, it's necessary to organize atomic sublevels in order of increasing energy. So now when we start talking, we're going to talk about energy from the lowest going up. So the lowest energy sublevel is always 1s sublevel. And then we go to 2s. Then we go to 2p, 3s, 3p, 4s. And when I explain this in class, it'll make more sense. So remember I talked about level 2 has 2 sublevels. And I'm going to show you a picture of this. I believe there's a picture on the next slide of this. So hopefully it's not like, what is she even talking about? Mom. So if you don't understand that filling order right now, don't worry. Hopefully the next picture on the next slide, I'll explain a little bit better. But like I said, when we fill sublevels, we always fill the lowest energy and then move up. So remember, I talked about the 1s or the s sublevel holding 2 electrons. So that means I'd have 1s2, 2s2, and so on and so forth. I'm basically describing the principle right now. Aufbau's principle states that all lower energy orbitals must be filled before the electrons can be added to a higher energy orbital. So if I start with hydrogen, hydrogen does not fill the 1s sublevel. It only has 1 electron. So I can't move on to 2s and say that's hydrogen because I don't have enough to move on forward. And I'm going to show you an example of this, so please don't freak out. When we talk about the total number of electrons, we actually get that from the periodic table. So we determine how many electrons an atom has, and then we would fill in the order that way. If you want to know which goes first as far as orbitals filling, we kind of look at this diagonal rule for electron filling order. So I would always fill in the 1s first. So let's say I'm talking about helium. Helium has 2 electrons. I would fill in 1s2. That's a full shell. Let's say I'm talking about the third element known as lithium. So I would have 1s2, 2s1. So I filled in the second, and it's not all the way full. This is clearly the s sublevel can hold 2 electrons. So then I can move forward with the fourth element, beryllium, 1s2, 2s2. Then I'd have to move on to 2p, 3s, 3p, 4s. Now, if you notice here, in this area here, notice that I went from 4s to 3d. And that doesn't sound like it makes sense, but when we're talking about energy, 4s sublevel actually has less energy than the 3d sublevel. It's all because of the electrons found in the 3d shell on the periodic table are actually much higher energy. And I'll show you this when we talk about, especially in the next video, when we talk about the periodic table and electron configuration. Now, in order to do this, in order to determine the electron configuration of an atom, first you need to know the number of electrons. So if you're struggling with that, please remember 8-man. Number of protons equals an atomic number, which equals electrons. Then you would fill electrons according to Aufbau's principle. So in this filling order, 1s, 2s, 2p, 3s, 3p, 4s, so on and so forth. So my example to you is carbon. Carbon has 6 electrons. So using this filling order, it would be 1s, 2, 2s2. I'm running out of room. Oh, well. 2p2. Now, p can hold 6 electrons, and that's in your notes when we talk about orbitals. But in this case, there's only total 6 electrons. Another thing you'll notice is that the subscripts equal the number of electrons present. So 2, 4, and 6, that's the number of electrons in carbon. So this is basically what I said on the last chapter or last slide. So I should have kind of scrolled over. So determine the number of electrons present in the atom based on Aufbau's principle, fill levels accordingly. So what do you think? This is just a question to test yourself. What do you think the electron configuration of neon would be? So neon, what is the electron configuration? And that's what I'll leave you with. I know that this is overwhelming information, so we are going to spend a couple days on this. If you have any questions, please make sure to ask me on Edpuzzle so I can figure out how to teach this in a better way that helps you understand.